Welcome to video lesson 12.6 on analyzing lines of fit. In this section, we're going to use residuals and find lines of best fit. Now, a residual, is the difference between the y value of a data point and the corresponding y value found using the line of fit. We try to see how well a line of fit models a data set by using residuals, And a residual can either be positive, negative, or zero, all right? So we're seeing by this graph here that a positive residual is when our line of fit, the point is above that line of fit, and a negative residual is when the data point is below that line of fit, Now, a scatter plot of residuals will show how well a model fits a data set. So if we're trying to determine, how well the line of fit actually models a data set, we're going to make a scatter plot of all the residuals. And if it's a good fit, then the residual points will be randomly dispersed about the horizontal axis. So we'll have random points above, below the horizontal axis. Or the x-axis. Now, if the model is not a good fit, then the residual points are going to form some type of a pattern. Might be a line that's increasing, a line decreasing. It might be a U shape, a N shape. Any type of pattern, if they're not just a bunch of random points dispersed about the horizontal axis, then the model is probably not a good fit. All right, for an example 1, we're using information back from yesterday's section 12.5, and we found the equation y equals negative 2x plus 20 as the line of fit for the information that's here. Now we want to find out, is the model a good fit? So the first thing we have to do is find the residuals. So our first step in answering the question if the model is a good fit is to calculate the residuals, and it's easiest to do this by organizing the results in a table. I already went ahead and put all the x values in. Now the y values will enter in here. Now the y value from the model means, using our equation, what is, when x is 1, what is the y value? So negative 2 times 1 is negative 2. Negative 2 plus 20 is 18. And the residual is the difference between those two. But we'll finish the y value models first. So 2 times negative 2 is negative 4. Negative 4 plus 20 is 16. So we'll go through filling in all these residuals. Or all those y values, from the model. Now, in order to get the residuals, we have to take, basically, again, because it's the difference between the y value of a data point and the corresponding y value using the line of fit. So we'll take 19 minus 18, which is 1. 15 minus 16, negative 1. 13 minus 14, negative 1. 11 minus 12, negative 1, 10 minus 10, 0, 8 minus 8, 0, 7 minus 6, 1, and 5 minus 4, 1. So those are our residuals. Now what we want to do is to use those points, the x and the residual, to make a scatter plot. Now our x values go from 1 to 8, so 1, 2, 3. And our residuals are really only from 1 to negative 1. So 1, 1, 2, negative 1, 3, negative 1, 4, negative 1, 5, 0, 6, 0, 7, 1, and 8, 1. And we can see from our scatter plot now that the points are randomly dispersed, about the horizontal axis. So, since the points are randomly dispersed about the horizontal axis, okay, the equation is a good fit. Okay, so that would be our overall answer. All right, so it's an awful lot of work to do to arrive at that answer, but that's how we figure that out. Okay. Now example 2 says, now the table shows the ages and salaries. It looks like I don't have the table here, so I'll need to write that down for you, sorry. And we want to see if the equation y equals 0.2x plus 32 will model the data. So let me make this table quickly for you. So salary and age, okay, 35 is 42. And again, the salary is in thousands of dollars, okay. Age 37, 44, 41, 47, 43, 50, 45, 52, 47, 51, 53 is 49, and 55, 45. Now, we need to list all the x values. 35, the y value is 42, 37, 44, 41, 47, 43, 50, 45, 52, 47, 51, 53, 49, and 55, 45. Now to figure out the y value from the model, I'll have to substitute in all these x values and get my y. So 0.2 times 35 plus 38 is 45. Okay. And I already have these completed. It'll take more time to actually complete them out on your own. Okay. Now to figure out the residuals again, that's the difference from the y value to the y value from when you substituted into the model, the line of fit. Okay. So 42 minus 45 is negative 3. 44 minus 45.4 is negative 1.4. 47 minus 46.2 is 0.8. 50 minus 46.6 is 3.4. 52, minus 47 is 5. 51 minus 47.4 is 3.6. And 49 minus 48.6 is 0.4. And 45, minus 49 is negative 4. Now what we need to do is use those points to make a scatter plot. And remember, if the points are randomly dispersed about the horizontal line, then the equation is a good line of fit. And if it is not, then it's probably a poor line of fit. Okay, and doesn't model the data well. So we have x values of 35 basically to 55. I'll just go up by 5s here. 35, 40, 45, 50, 55, 60. Okay, and our y values, the residuals went from a high of 3.6 to a low of negative 4. So 1, 2, 3, 5, negative 1, negative 2, negative 3, negative 4. All right, so 35, negative 3, 37, negative 1.7, 41 is 0.8. Okay. 43 is 3.4. 45 is, excuse me, 5. Sorry, that was the highest, was 5. Okay. 47, 3.6. 53 is 0.4. And 55 is -4. Now we can see from the scatter plot that basically the points form a kind of an N-shaped pattern. Anytime they form any kind of pattern means that it's not really it doesn't model the data well. So the points form and kind of like an N pattern. Okay. Therefore, the equation y equals 0.2x plus 38 does not model the data well. Okay, so it's not a very good line of fit. All right, now we have some more information. Graphing calculators use a method called linear regression in order to find a precise line called a line of best fit. Okay, because the calculator can do things obviously a little bit more efficiently, better than what we can to save time, and so it's a more precise line that's called a line of best fit, not just a line of fit. The line of best fit models best models a set of data, okay, and basically because when the calculator finds the line, the linear regression, it uses every point, okay, to find that equation, whereas we just use 2 points to find the equation. All right. And a calculator often gives a value r called the correlation coefficient, and that value tells whether the correlation is positive or negative and how closely the equation models the data. So values of a correlation coefficient range from -1 to 1, and when that correlation coefficient r is close to -1, there would be a strong negative correlation. If it's close to +1, there's a strong positive correlation. And when r is close to 0, there's a weak correlation between the variables. Okay, and that little chart sort of shows you that information. Now, when you have a change in one variable x that results in a change in another variable y, that's called causation. Okay, and causation produces a strong correlation between the two variables. Now, the converse of that is not true. So in other words, a correlation does not imply causation. Okay. Now, example 4 says, tell whether a correlation is likely in this situation, and if it is, tell whether there is a causal relationship. Okay. Explain your reasoning. So the time spent exercising and the number of calories burned. Now, is there a correlation between that? The more time you spend exercising, the more calories you are going to burn. Yes. Okay. And does that cause, okay, so does your time spent exercising cause more calories to be burned? Yes. Okay. So in this case, there is a positive correlation, okay, and a causal relationship because the more time you spend exercising, the more calories you're going to burn. All right, so if we graph that, it would definitely be a positive correlation kind of scatter plot type of thing. Now, how about the number of banks and the population of a city? Okay, well, there could be more banks, and that could mean that the population of a city is larger. But if you made more banks, would that cause the population to increase? No. Okay, so in this case, there could be a positive correlation, but there's no causal relationship because building more banks will not cause the population to increase. Okay? All right. Now you have 2 practice problems. Okay? Please do your best And make sure you write down any questions you have from this section and be sure to ask them in our next class. Thank you. Have a great day.